So if we're looking to see where you get intersecting lines and circles, what we're talking about is finding points, okay? So if I have my circle here, C, and my line here, L, and I'm asked where do they intersect? So if the question was, where do they intersect? Okay, where do they intersect? Well, look at them and see, right, intersecting means crossing. So where are they hitting each other? Where are they crossing over each other? Well, they're crossing over each other two places. Right there. Right there, they cross over each other. Where are those points? Those points, very easy just to read off. The first one here, if I'm looking at it, this is out 6 and up 3. So 6, 3. 6 on the X, 3 on the Y. Okay, so that's 6, 3. That's where that point is. And this other one up here, it is out 3 and up 6. So that's very easy. The line and the circle intersect at the points 3, 6 and 6, 3. That's very easy to read off. Again, if I get other circles and different lines, different circles, and I was asking where do they intersect, if I'm looking at the first one here, I have a circle here and I have a line here. So where are they intersecting? Well, they just seem to brush off each other at one point. If they're brushing off each other at one point, again, I can say they're intersecting at that point. Well, they're intersecting right there. And that point is -1 and then up 1. So that's the point where they intersect. They just brush off each other at that point, and that is the point where they intersect. Okay. The word for when they're intersecting at just one point, because in general they'll do it at two. In this case, the circle and the line, just one point. This line is said to be tangent to the circle. Okay, just touches it at one point. That's just a little extra. In this other circle here, other line, again this one, same idea. If I was asked where does the circle intersect with the line, I look and see where they cross each other. Okay, and they're crossing here and they're crossing down here. So where's those points? Well, this one up here, I have it already filled in. It's a 4, 2, because I've come out 4 and I've gone up 2. So that's the point 4, 2. The bottom one here, this one, where's that point? That point is, well, it's out -4 and it's down -2. So that's where that point is. So the intersection is where are they intersecting? Well, they're intersecting at the points 4, 2 and -4, -2. So when we have the drawings, they're very easy just to pick out what's going on. Going on a bit further, same type of question. It says the diagram shows the line x plus y plus 1 equal to 0. So it gives me the equation of the line there. Okay. And the circle x squared plus y squared equals 13. So the circle has an equation of that. Okay, so there's the line and the circle. And the first thing they ask is use the diagram to determine the coordinates, the point of points of intersection between the line and the circle. So again, the points of intersection are where they're crossing each other. So where does that line and that circle hit each other? Well, they hit each other down here and they hit each other here. So what are those points? Well, this one down here is out 2 and down -3. So 2 -3 is that one. And then this one up here is -3 out and 2 up. So there's the point. So these points of intersection are right there. -3, 2 and 2 -3. So nothing too bad. Now, if it says using algebra, confirm your answer. So if I want to use algebra to confirm that the points of intersection are actually these points, I have to use the equations for the circle and the line. Okay, so the line, the equation of that line, it told me on top here, was x plus y plus 1 equals 0. The equation of the circle was x squared plus y squared equals 13. Now, if I want to solve these two equations to find out, or to prove that this is actually where they're crossing, I have to solve them using simultaneous equations. Okay? The reason I have to use simultaneous equations is because in in both equations I have two things I don't know, and I can only solve for equations when I have more than one thing that I don't know with simultaneous equations. That's the best way to go about solving them. Okay, so going on to a new page here, I have again the equation of the line was x plus y plus 1 equals 0. The equation of the circle is x squared plus y squared equals 13. Now if I want to solve simultaneous equations like these, when I'm involving squares, what I do is I take the top line, the linear one, okay, and what I do is I get x on its own, or y on its own, it doesn't actually matter. But what I'm going to do is I'm going to take this line, and I'm going to get it and set it up so that it looks like this, x equals. Now the way I can do that is I'm going to take everything and bring it to one side so that I have just x on its own. So when I bring over the y, it'll be minus y. When I bring over the 1, it'll be minus 1. Okay, so now I have a little equation, and what I do is I sub him in to the bottom equation here. Everywhere I see an x, I can sub in this equation. So it goes x squared, so I can go minus y minus 1 squared instead of the x, plus y squared, so plus this y squared, equals 13. Okay, now I'm going to have to tidy it up. So I have this here, this expression here. Now that is the same as saying, if I just take it over here, minus y minus 1 squared is the same as saying minus y minus 1 times minus y minus 1. So that's the same as having brackets back to back. How I deal with brackets back to back is I multiply them out using the box, or whatever way you want to. So if I'm to multiply out minus y minus 1 times minus y minus 1 using the box method or whatever method you use, I will set it up like this with minus y minus 1 along the top and then minus y minus 1 along the bottom. Multiply out each bit, so I'll go y times y gives me y squared. Minus 1 times minus y gives me y. Minus 1 times minus y gives me y again. Minus 1 times minus 1 gives me plus 1. So next bit is I take all these bits, and instead of having this big bracket with a squared, I can replace it with all those bits. So I'm going to put them in instead of it. So all the bits are y squared plus a y plus another y plus a 1. And then I'll continue on with the plus y squared, this one, equals 13. Okay. The next thing is I'm going to try and tidy everything up. So what can add together? Y squared and a y squared can add together. So that's 2y squared. A y and a y, they can add together. So that's 2y. Plus 1 equals 13. Okay. Next thing, get everything to one side. So I'll have 2y squared plus 2y plus 1 minus 13 when I bring it over. Tidy it up, I'll have 2y squared plus 2y minus 12 equals 0. Okay, so from here I need to try and solve an equation when it has a squared going on in it there. Now how I solve that is fairly simple. I look at it, so as a 2y squared plus a 2y minus a 12 equals 0. Now I look at it and I say, right, there's something with a squared, there's something with just a letter, there's a number on its own. That's a big giveaway that it's a minus b formula is the way I can go about solving this. Okay, again, just thinking in your head, okay, or remembering or looking for it, your minus b formula is as follows. Okay, there's my minus b formula, so I need to start filling that in. To do that, I need an A, a B, and a C. A is 2, the thing that goes with the y squared. B is also 2, but this is the thing that goes with the y. C is minus 12, which is the number on its own. Okay, filling it into the formula, it'll go minus b, which is 2, plus or minus the square root of b squared, so it's 2 squared, minus 4 times a, which is our 2, times c, which is minus 12. all over 2 times a, which is 2. Okay, I'm going to do this into my calculator. I'm going to do it twice. Once when there's a plus, once when there's a minus. That will give me 2 answers back, and my 2 answers are for y. Okay, that will give me 2 answers back, and my answers are y equals 2 and minus 3. There are 2 answers for y. Now, if I want to get the answer of x, it's very simple. I'm going to just go back up to the equation I made. Okay, or the equation I made, or the top line here. So there's the top line. X plus y plus 1. So it's x plus y plus 1 equals 0. And everywhere I see y, I can sub in a 2. Okay, so I'll go x plus 2 instead of the y plus 1 equals 0. That will have me with x plus 3 equals 0. So therefore x is going to be equal to minus 3 when I bring it over. Okay, so I have one answer there. I have my x answer, and I now have my x answer, and I have the y answer that goes with it. So that means I have a little pair going on of a minus 3 and a 2. Okay, for the x and the y. And do the same thing with the other one there for the y. So I have a second y answer. To get your second x answer, use the equation again, the top line. But this time sub in minus 3 everywhere there's a y. So it'll be x, y plus y, so that's adding in minus 3 instead of y, plus 1 equals 0. So it'll be x minus 2 equals 0. X equals 2 then when I bring it to the other side. So that leaves me with x is 2, y is minus 3. So the second little point I have there is 2 for x, minus 3 for y. Okay, that's your x, that's your y. Now, why are these answers significant? If I just go back and keep them in mind now, and go back and look at my circle and my line, that's where I said they were crossing. Okay, again, just bringing it back. I said they were crossing at the point 2 minus 3 and the point minus 3, 2. And look, those are my answers. Minus 3, 2, 2 minus 3. So if you want to solve where a line, okay, I'll just clearing that off a little bit, where a line and a circle intersect, and you want to do it with algebra, you will have to use simultaneous equations to do it.